Yeah, very good evening, DS. Very good evening. Now, welcome to the ACE online and also ACE online, dear. Yes, ACE online and also welcome to the ACE Engineering Academy. Now, coming to yes, myself, I am Jnaneshwar. So, today my subject name is control system. Control system. The topic today important concept for the gate and ESE. Now we are going to discuss one. I am going to select one concept. So I am going to solve gate and ESE questions. Subject control system branches is ECE electrical instrumentation. Now subject, okay, syllabus for the control system. Basically, what is the syllabus for the control system? Now observe. This is the syllabus for the control system. From this topic, I am selecting one of the topic here. Okay, teaching all chapters in within 1 hour it is not possible. So I am selecting one topic here. What is the topic here? Now observe the topic name here. Yes. Today I am going to teach some of the important questions related to the Routh-Hurwitz stability method. To find the stability, one of the scientists is Routh-Hurwitz. So we will discuss the stability. In this one, in the chapter, what are the main concepts here? What are the topics here? Important topics in the Routh-Hurwitz stability chapter. Stability introduction. What is a stable system? What is an unstable system? What is a marginal stable system? And also, after this one, RH stability criteria. To comment the system is stable, what is according to the RH? What are the stability conditions? Next one. Yes, RH difficulties means first column element is 0, what happens? What are the rules and regulation? If an entire row is 0, what happens? So that things we will discuss at the RH difficulties. Then relative stability. So we have the absolute stability as well as relative stability. So so relative stability, what is the relative stability? How to find the relative stability here? Next one, what are the advantages and disadvantages of the using RH method? Advantages, it is a simple as compared to all the stability method. As compared to the root locus, Bode plot, polar and Nyquist, it is a simple technique. That is advantage. We will discuss. Okay, if you have the time. Then some of the previous questions also will discuss here. Some of the previous questions also will discuss. Okay, fine. Now, first thing, what is a stability analysis? First thing we will discuss what is a stable system. It is a control system heart. Now, what is the stability? Stability means we define. First, a system is classified into 3 types here. Mainly, any system is classified into 3 types here. What are the 3 types? Come on. Now, first one is stable system. Second one is unstable system. Third one is marginal stable system. So we define in the quick mode what is a stable system. Now, first one, stable system. For any system, if the input is bounded, the output should be bounded. That type of systems are called as stable systems. Okay, now what is a stable system? If the input is bounded input, output should get the bounded output. This type of systems are called as a stable system. So now definition, same thing I am providing it. Yes, what is a stability system? In an interview, if you face any interview like ISRO and ESE means if you observe ESE interviews, then there is chance of what is the stable system? Stable system. So for bounded input, if the output is bounded, that type of systems are called as a stable system. Actually, what is the meaning of bounded? Bounded means what? Bounded means what? Minimum to maximum, all values should be finite. What is the minimum? Time t equal 0 to time t equal infinity. Now bounded meaning I am providing. Bounded means minimum to maximum, all values should be finite. This is called as a stable system here. Now, if you want in the here, if the output is like this, one of the sample example I am providing, if the output is like this. Now, this is the time. Suppose x-axis is the time, independent variable is time. Now, as time reaching minimum, 0 to maximum value is reaching, output should approach the like this, output is reaching like this. So, it is output at any time period, output is finite only. So, that is a bounded output we are getting. This type of outputs are called as a bounded outputs. Instead of like that, if the output is moving like this, so with respect to time, now output is moving like unbounded. This type of systems are called as unstable systems. So that is unbounded output here. This is called as unbounded output. Okay. Now, this is the meaning of stable system. This is the meaning of stable system. Once. So similarly, we'll go for unstable system. Unstable means for input is bounded only, but output is unbounded output. Unbounded output means here I am showing this. Just now we were discussing unbounded means now time t, yes, from minimum to max, the output is also approaching to the infinity. This type of unbounded output. This output is called as not a bounded, unbounded output. If you provide the unbounded output, that type of systems are called as unstable system. Now definition here, for a system if input is bounded but output is unbounded, then that system is called as unstable system here. Now next, if you move what is stable, what is unstable here, I'll give the simple examples here. First thing, now once more, output is under the control of input, that system is called as stable system. If the output is under the control of input is called as stable system. If the output is not under the control of input, that type of system is called as unstable system. For stable system, we'll observe. Now, for stable system, bounded output and for bounded input, there is a definition. A system is said to be stable if its output is under the control of input. It is important. Output is under the control of input, that type of system is called as stable system, under the control of input. For a stable system, output is under the control of input here. This is a stable system. Now third type of system is there. Now what is the third type of system? Input is bounded only, but output is neither bounded nor unbounded. Here this type of systems are called unbounded, marginal stable system. Neither zero nor infinity. It continuously make the oscillations here. This type of systems are called as a marginal stable systems. Means, so continuously oscillate this type of. Now it is not moving. Observe, I am taking one more example here. The sine signal if you take, it is not ending like this. It is not a marginal stable. Continuously make the oscillation. This is also not a marginal stable system. If it is amplitude increases like this, it is also unstable system. This is not a marginal stable. This is also not a marginal stable. Constant amplitude here. It is a constant amplitude and also fixed frequency. This two signal frequency, this signal frequency should be same only. That is a reciprocal of time period is called as a frequency. It should oscillate with the same frequency. So means now what I am here telling, yes, one signal is like this, other signal is this like this, means it is not a marginal stable. So any two, if you take this time period should be same. So marginal stable system make the oscillation continuously with a fixed frequency. That type of systems are called as a marginal stable system. So definition will observe. For a bounded input, if the output response maintain constant amplitude and constant frequency is called as a marginal stable system. So what happened marginal stable system? Yeah, it is neither zero, it is not settling zero nor infinity. It is neither zero nor infinity. That type of systems are also called as a marginal stable system. For a marginal stable system, as t tends to infinity, the output neither becomes zero nor approaches to infinity. This type of systems are called as a marginal stable systems. So marginal stable system make the oscillation continuously with a fixed frequency. That frequency name is called as a frequency of oscillation. Marginal stable system make the oscillation with a fixed frequency. That is called as a frequency of oscillations. Now marginal stable system other names here. What are the other names for the marginal stable systems? Now we can call it as a just stable, and now critically stable or maximum value of k for stability. So these are the other names. Previously ECE gave 2 mark question. They were asked the maximum value of k for system stability. Majority students were calculated condition for stability, but it is if the question asked like this, you need to find the condition for marginal stability only dear. Marginal stability. Maximum value of k for stability now means that is a marginal stable only. These are the other names, and one more other name famous undamped system also, marginal stable system. Now let us, I am providing some with small animation here. What is that one? I am going to explain the what is a stable system in another word. Once again conclusion. So what is the once again conclusion here? Let us. What is a stable system? In a control system, you should know the what is the stability. What is the meaning of stability? Output for bounded input, output should be bounded output. That is a stable system. One type of definition. Second type definition, output is under the control of input. That is called a stable system. Output is under the control of input. Now third way of definition, any small changes in the input, there is no big changes in the output, that type of systems are called a stable system. Because of small changes, there is no big changes in the output, that type of systems are called a stable system. Let us, I am going to show with you animation here. Yeah, there is a base here. On the base, this cone is standing on the base here. Now I am touching to the base, small, okay, okay, normal force I am applying, small force I am applying here. So for small change in input, okay, it settles sometime, after some time it is going to settle on the base only. This type of systems are called as a, okay, stable system. There is no big change. If any small changes, but there is no big change in the final output, is called as stable. Now for marginal, okay, unstable I am showing. Same ear cone standing like this here. Same cone standing like this. If you touch, okay, small force here. Not small force is required. If you do like this, so system, okay, that may fall down or break down also. This type of systems are called as unstable system. Any small changes but big changes in the system. Any small changes in the input, big changes in the output, that type of systems are called as unstable system. Now, yes, three system observe here at a time. So small changes but there is no big change, stable system. It damages. It is in between, it is sleeping. Like this type of systems are called as a marginal stable. So for time being, I have selected this type of animation here. Okay, fine. Now, let us, based upon this minimum introduction is required, let us based upon this topic, what are the questions are asked here. This is a gate question. Now come on, select the right option here. Now I am providing the option. Come on, interact with me. What is the best, okay, what is the suitable correct answer? So these are the options here. In fast mode, I am asking, what is your answer here? Yes, what is your answer? No. Yes, I am checking your answer. Yes, dear, come on. Yes, any answer from you people? Hello, dear, any answer from you people? Come on. Yes, select this is one of the gate question. No, I am checking. Yes, I am waiting for you. Yes, I am not getting. Yeah. Any reply? Any reply from dear? Yes, waiting for eagerly for your answer. No. Yes. Now here I am checking your answer. Let us now explanation for stability system. For stable system, all poles should be in the left half of S plane. For stable system, all poles should be in the left half of S plane. So yes, here all poles of the system must lie in the left half of the j omega axis. Examiner is asking which of the following statement is not true. Not true for the stable system. For stable system, which is not true. For all the poles of the system lie in the left half S plane. Yes, this statement is correct only. Option A is correct statement only. Is asking not correct statement. Zeros of the system can lie anywhere in the S plane. Dear students, for stability decided by only location of the poles only. Only location of the poles only. If the poles is this side, stable system. Any pole this side, unstable system. Poles, all poles are this side. If any zero this side or this side, doesn't matter. It is a stable system only. Stable system only. stable system only. Suppose if the system is like this, now all poles here this side, one pole is this side, then it is unstable system. So for stability, all poles should be left side. So first statement is correct. Zeros of the statement can lie anywhere. So this is also correct statement. All the roots of the characteristic equation must be located on the left side of j omega axis. First one and last one is same only. Roots also same only. So D also correct statement. What is the C? All the poles must lie in the mod values given. Mod means now plus minus or plus or minus 1. C statement I am writing. So according to C statement, one pole at minus 1, one pole at plus 1 here. So mod means plus or minus. Okay, plus or minus one position. So one pole is left, okay, right side, this is unstable. So this is not correct for stability. It is not corrected here. So what we can say is asking to pick the not correct option. Option C is right answer. Similarly, check it. One more question here. Yes, if all the roots of the characteristic equation have negative real parts, then the system stability is. All have negative real parts. ESE prelims paper 2020. Now check it. What is the correct option here? Now, okay, I'm checking your answers here. Yes. Yeah. Now, okay. Yes, correct, dear. Now, negative real parts. Examiner was given negative real parts. Very simple question it is. Negative real parts means, now I am taking here, there is a one pole here. S is equal to minus 1. Now S equal to minus 2. It is a negative real parts. So all the poles are negative real parts. Then the poles should be in the left of first plane only. Negative real parts means they are in the left side only, left of first plane only. So no doubt the system is stable. Any system is a positive real part. Any system is having positive real part. Suppose this is a positive real part here. Observe. Now at S equal to minus 1. Now one more S equal to plus 2. It is a positive real part. Positive real part means what? Positive real part. Then system becomes unstable here. For negative real part, system becomes stable only. This question was given ESE prelims 2020 based upon the stability. Then we will enter into the, before entering to the Routh-Hurwitz stability method, stability introduction we were discussing till now. It is also used for the interview point of view. Now, okay, fine. So, next, purpose. What is the purpose? To find the stability, to find the system stability, and to find number of poles lies in the left side, right side, or on the imaginary axis. This is the purpose. These points are useful for the interview point of view also. To find the range of K values for system stability, that is the conditional stability. Then to find the frequency of oscillation for the marginal stability. Next, what is the condition here? Now to find the stability by using RH, we require the characteristic equation. That is the characteristic equation we require to find the stability. What is the stability condition in quick mode? For the stability, all the coefficients in the first column only. Here. All the stability, okay, in the first column should have the same sign, and the last S40 coefficient constant term should not miss. Okay, it should present only. If any changes in the first column, then the system become unstable. Okay, some of the numericals will discuss different models in the complete chapter. To teach this chapter, minimum 7 hours is required, but 7 hours I am going to cover all the different models, important models I am going to cover within the short time. And yes, this is a very regular, by observing the previous papers of the GATE and ESE prelims, I have selected from the each model one question. If you are my student, already you know these models, these problems also. Now solve along with me. Okay, take the pen and paper, solve along with me. First I am starting third order characteristic equation. Yes, this question was given instrumentation gate, starting with third order. Simple question, starting with third order. So examiner is asking condition for stability, So a system with having characteristic equation, the condition for examiner is asking condition for stability. This is a characteristic equation is given. Now dear, what is the characteristic equation here? Now I am taking the RH method here, tabular column. First coefficient of the S431. 1. So I am writing coefficient of S431. 1, S43, now S square, S41, S40. Now coefficient of S43 is 1, so I am writing 1. Alternate element, after 1 alternate element is now C, S coefficient C. Now after this one alternative odd numbers, no means 0. Let us even number B, S square B, after B next to 1 ending. So these are elements. Now come on, according to the RH stability, multiply this to BC minus 1 into 1. So B product of C minus 1 into 1 upon B. This is one thing. Now next element, this two product, B product of 0, 1 product of 0 by B. So no doubt we will get the 0 answer here, 0 only corresponding this element. Now after this one here, observe. Yeah. Next to multiply this 2 minus this 2 upon this element. So no doubt this element you will get the answer as a 1 dear. 1. You can check it 1. Now examiner is asking for stability. Stability means this is a positive. This is a positive. So obviously this 2 should be positive. Already examiner is given positive coefficients. All are positive coefficients. So ABC are positive coefficients only. So this is also positive. But we don't know this value. So it should also positive. Positive. For stability, so BC minus 1 greater than 0. So no doubt BC greater than 1 here. No doubt BC greater than 1 is perfect answer. BC greater than 1. So what is the correct answer here? Option B is the right answer here. This is the instrumentation gate. Now I'll check your answers. Instrumentation gate here. Yes. No. Yeah, give the response. Now, yeah, instrumentation gate, this is a next one. I am moving to the next question. Okay. Now, one more question. So, let us. The closed loop transfunction of system is given. This is system electrical ESE, engineering service examination prelims paper. Now, what is the system here? The system is asking. Whenever closed loop transfunction is given, how to find the characteristic equation is nothing but directly denominator part. Examiner is given closed loop transfunction or simply transfer function also, consider by default it as a closed loop transfunction only. If the question is given simple transfunction or system transfunction or closed loop transfunction, consider it as a closed loop transfunction only, directly take the denominator part here. If the examiner is given open loop transfunction, then characteristic equation formula we have to use 1 plus g of s h of s dr. Question is given like this. By directly closed loop transfunction is given, you have to take the closed loop transfunction is nothing but, so what you have to take, come on here. Now s power 3, s square, s41, s40 here, s40. So 119 coefficients here, 119, 0. Next to 8, 12. Alternate elements you have to arrange 8, 12, 0. Now this two product 8 into 19 minus 12 upon 8, 0. This is 12. Now come on, tell me that here it is a positive. It is also positive. 8 into 19, that is a big number, minus 12. It is a big number. So you will get the big minus small, large number minus small number, you will get the positive only, no need to calculate. So all are having same sign in the first column, the system is stable system only. Now here, so obviously option A is correct here. Option A is correct answer. Now next one. Yes, we'll go for one more question. Come on, solve this question, whether it is stable or unstable here, whether it is stable or unstable. Now one more question here, practice point of view. Yes, now tell me, this is a s power 3, s square, s power 1, s power 0. So coefficients are 1, now 3, 0. Odd numbers 1, 3, no numbers, so 0. Again even number start, s power 2, coefficient 2, minus 4, 0. Now come on, 2 product of 3, 6 minus of minus 10. 10 upon 2, this element is 5. Now this element is 0. Out of this 4 element, one element is 0, means next element should be minus 4. So the system, tell me here, what is the system here? Unstable, no doubt the system is unstable here. The system is unstable. How many number of right side poles here? Right half of S plane, right side poles here. Right side poles, right poles here. Right side poles equal to number of sign changes here. Number of sign changes. Here positive, positive, positive to negative. Only one change. So right side poles equal to 1. Left side poles equal to. Left side poles equal to. Now total poles. Total means highest power is 3. 3 minus right side poles. 3 minus 1, 2 here. So this much of risk is not required. Simple logic here. Simple logic. What is the simple technique here? How to comment the system stability without using RH method here. RH method. In the first, in the characteristic equation, positive, this is a positive, this is a positive, negative. Sign has been changed itself in the characteristic equation. If any sign change in the characteristic equation, no doubt the system should be unstable only. The system is unstable only. In the characteristic equation, if any sign changes occurs, so without doing this RH method, this much of risk is not required. This much of risk is not required. All this one not required. So directly you can comment the system is unstable here. Directly you can comment system is unstable here. That is simple technique here. That is simple technique here. Now I am checking your answer. Yes, actively participate here. Actively participate the system. Note here, Abhishek one time given unstable. Okay. Yeah, right. Next question. Try next question here. It's higher order. We are moving to the higher order. Here, any answer for this question here? Now tell me here. This question, observe characteristic equation for each model. I am selecting one question. S power 5, 4s power 4 plus 3s cube plus 2s plus 5 equal to 0. Now anything notice here? Now s square term is missing. 0 into s square. Any term is missing. That term you have tried 0 into s square here. 0. 0 you have to, okay. Means every coefficient should be present. 5, 4, 3, 2, 1. Then arrange, then only solve the question here. Now I arranged here 0 into s square. Come on, use the RH method here. Use the Routh-Hurwitz method. Use the Routh-Hurwitz method here. Now s power 5, s power 4, s power 3, s power 2, s power 1, s power 0. Now coefficient 1, 3, 2, 0. Alternate elements 4, now 0, 5, now 0. Here out of 4 elements, this element is 0, next element would be above 0 element. Again here 4 elements, 4 product of 2, 8 minus 5, 3, 3 upon 4, 3 by 4. So these 2 are 0, so this element is 0. Next 0 minus 4, 4 cancel, so minus 3 by 3, so you will get minus 1. Now out of this 4 element, this element is 0, so next element would be 5. This is 0. Now next calculation, minus 3 by 4, minus 15. So upon minus, so after simplification calculation, you will get the minus 3 by 4, minus 15, 60. So plus 63 by, okay, minus 3 by 4, 3 by 4, 60, 15. So 63 by 4 approximately you will get now 0. So out of 4 elements, this element is 0, means last one is 5 only. Now here compare first one positive, 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 negative sign, positive, positive. So sign has been changed, so system is unstable here. System is unstable here, no doubt. System is unstable. System is unstable. How many sign changes now tell me? Right side poles equal to, right poles equal to, RP means right poles, I am writing short. So right side poles equal to positive to negative change, positive to negative 1 change, again negative to positive 2 changes here. So right side poles equal to, how many left side poles? LP means left side poles equal to, highest power is 5, highest power is 5. So 5 minus right side poles equal to 3 here. So right side poles is 2, left side poles is 3. But this much of risk is not required. Directly we have the technique here. Yes, what is the technique here? From the beginning, from first to highest coefficient to lowest coefficient, all terms should be present. Missing of any coefficient here, missing, so system becomes unstable. Directly we can comment. Missing of any S term, then the system becomes unstable. Directly we can comment. This much of risk is not required in the GATE exam. This much of risk is not required. So for each model, I am telling the technique, regular method as well as technique here. So here observe. So we can say that missing of any S term, system becomes unstable here. Then another type of model, first column element is 0. If the first column element is 0, what happens in the Routh-Hurwitz stability? First column element is 0, what happens in the Routh-Hurwitz stability method? Now we'll solve this question. We'll solve this question. Now s to the power of 5, s to the power of 4, s power 3, s square, s power 1, s power 0 here. Now how to solve this type of questions here? Now yes, 1 coefficient, next to 2 coefficient, next to 3, 0. Now even number, here 1 is there, here also 1. Now next to after 1, 2, this is a 15, 0 here. So 2 minus 2, 0. Now 3 minus 15, that is nothing but minus 12, is 0. Here we got first element is 0. First column element is 0. What to do? Press series. What is the press series? Now step number 1. What is step number 1? Substitute 0. That 0 with the smallest value of 0, that is the epsilon. Then step number 2, continue with epsilon. So what I am doing here, 0 I am substituting with epsilon. Continue means, now tell me, continue means 2 epsilon minus of minus 12 plus 12 upon epsilon, this is 0. So 15, this is a 15. Why? Because out of 4 elements, this element is 0, above 0 element 15. This is a 15. Next calculation, multiply this 2 minus this one upon this one, but it is a more lengthy. Let us assume this value as, I am taking this value as, whenever lengthy term you are getting, then assume this value as some x. These are tips here. Now minus 12x here. Here tell me, minus 12x minus 15 epsilon upon x here, 0. So last element is 15 here. Now come on, comment the system stability here. For commenting system stability, comment the system stability here. Positive, again resubstitute epsilon with 0, positive, we know positive. But you don't know the s square, s power 1 coefficient here. So what we need to do, s power 2 coefficient here, Now 2 epsilon upon epsilon plus 12 upon epsilon. So this cancel wherever epsilon is 0. So 2 plus infinity, that is nothing but plus infinity only. Positive you are getting. This element is positive only. Now coming to the s power 1 coefficient here. So what I am writing, minus 12x upon x minus 15 epsilon. Epsilon means 0. So x is cancel. What is the value you are getting? Negative, minus 12 here. So this is nothing but negative here. This complete term you are getting negative. Sign has been changed. So the system is what system? Unstable. This type of system is called as unstable. So unstable means same. How many sign changes? Positive to negative 1 change, negative to positive 2 change. So right side poles is 2. Left side poles is how much? Come on, tell me. Now 5 minus 2 equal to 3. This is a method here. Important concept here. This is for this model type of question you have to solve like this here. For this type of model we have to solve like this. Next, one more type of model here. Now, yes, one complete row is 0. One entire row becomes 0. How to solve this question? One complete row 0. How to solve the question? So this is a question, s power 5, s power 4, 3s cube, 3s square plus 2s plus k, 2 equal to 0. Now I am solving the question. So one entire row is 0. How to solve this type of question? S power 5, s power 4, s power 3, s power 2, s power 1, S4 0. Now coefficient 1, 3, then 2, 0, 1, then 3, 2, 0. Come on, help me here. Help me. 1, 3 minus 3. What is the answer? 0. 2 minus 2, 0, 0, 0. Complete row 0. If you get the complete row 0, how to solve this type of question? If the complete row 0, what is the procedure here? Now, first step, we have to write the auxiliary equation. Step number 1, write the auxiliary equation. Write auxiliary equation. Auxiliary equation. Write the auxiliary equation here. Now, what is the auxiliary equation for this one? Tell me. What is the auxiliary equation for this one? So, above 0 row coefficients is called as auxiliary equation. Above 0 row. So, 1 into S power 4. So, I am writing auxiliary equation as 1 product of S power 4 plus 1 product of S power 4, next element 3 alternate S square, 3S square plus 3S square plus 2S power 0, 2S power 0, 2S power 0 plus 2S power 0 equal to 0. Once again I am telling, what is the auxiliary equation? Just to above row coefficients, write a equation just to by 0, above 0 coefficients, 1 S power 4, then alternative S square into 3, then alternative S power 0 into product of 2. So now after writing auxiliary equation, what are the elements we got it? Now differentiate this one. Step 2 here. What is the step 2? Second step. Now differentiate above auxiliary equation. Differentiate above auxiliary equation. Differentiate above auxiliary equation. Now after differentiation, now tell me. So 4s cube plus 6s plus s power 0 is a constant 1. This is completely 0 only. Substitute above coefficient. This 4, 6, 0 is there. Na? Substitute these elements in the place of 0, then continue. Now I am substituting 4, 6, 0 in the place of 0, then continuation. So what are the 4, 6, 0? Continue the process. Next 4 product of 3, 12 minus 6. 6 upon 4, that is nothing but 3 upon 2, 3 by 2. Now out of 4 element, this element is 0, above 0 to 0. Next, this 2 product, 6 product of 3, 18 by 2, 9, minus 8, 1 upon 3 by 2. 1 upon 3 by 2 means, this is a 2 by 3, this is 0. Out of 4 element, this 0 means last element should be 2 only. Now all are having same sign, but one entire row is 0. Whenever one entire row is 0, all are having same sign, this system is called as a marginal stability here. All are the marginal stability condition, all are having same sign, and only one row 0, only one row 0. If 2 rows 0, that becomes unstable. Only one row 0, that type of system is called marginal stable. There is a proof is there, but simply I am writing marginal stable system. The system poles exist on the imaginary axis. On imaginary axis, so how to check the imaginary axis only. So that we will discuss in the next model. How to check that point. Next, one more different model here. One more different type of model here. Conditional stability system. Conditional stability system. One more model. It is a most important. And the IES and GATE also a repeating model. It is a repeating model. In the chapter, most repeating topic here. Many times the questions were asked from this topic here. Yeah, characteristic equation is S power 3 8s square plus 4s plus k. This is one of the IES mains question. Find the range of k values for closed loop system stability. Now second question, find the k value to become the system marginal stable. Find the frequency of oscillations. This is one of the previous question. Now one by one we'll observe. First characteristic equation. I am checking the condition for stability. So I am taking this one S power 3, S power 3, S square, S power 1, S power 0. Here observe. Once again question. This is a question. If possible, now try to solve the first question. Yes, try to solve the first question. Okay, nice. Okay, fine. Here I am solving the question one by one. What is the element is given? 1 is given. 1. Next to 4. Next to odd number 0. Then 8. Next to k 0. Yeah, important models I am selecting. Don't worry, if you are my student also try to solve the question. What are the important models they are asking, and previously selecting question I selected here, previously repeating questions. Now 8 4 ja 32 minus k. 32 minus k upon 8, this is a 0. Out of 4 elements, 0 means this is a k dear. So for stability, all the first column elements should have the same sign. For stability, all the first column elements should have the same sign. It is also positive, it is positive, compulsory, this should be positive, this should be positive. So for stability, what is the condition? For stability, the condition is, first one, k must be greater than 0. Okay, not only k greater than 0, not only k greater than 0, and also, and not only it is positive, it should also be positive. This should also positive. That is the reason why and symbol, and 32 minus k greater than 0 dear. K greater than 0 and 32 greater than k. So both combinedly, condition for stability, condition for system stability. Now help me. 0 less than k less than 32 is the correct answer. In between 0 and 32, then only system is stable. Once verify from the options here. Examiner is going to provide the option. Now less than 32. I am selecting more than 32. Let us in the place of k 33. I am selecting more than 32. 32 minus 33. Then minus 1 sign has sign has been changed. So system becomes unstable. Is asking condition for stability. If the options are given, then you can verify from here also. Okay, fine. Now next second question, condition for to become the marginal stable. Marginal stable means one complete row should be 0. One complete row should be 0. Logic, odd number row should be 0. There is a rules. Okay, now odd number should be 0. For this one, what I am telling, odd number should be 0. So this should be 0. For marginal stability, 32 minus k equal to 0 dear. For marginal stability, for MS, 32 minus k equal to 0. So what is the k marginal value equal to? K marginal value equal to 32. It is the second answer. From the option, if you substitute 32 minus 32 0, one row, okay, one complete row is 0. That is the odd number row 0. Then we can check that, say that it is a marginal stable system. Now third one, frequency of oscillation is asking. The procedure to find the frequency of oscillation. Frequency of oscillation we are going to find the for only marginal stable system. So how to find the marginal stable frequency of oscillation? The procedure, one entire row 0 na? When k equal to 32, one entire row 0. Write the auxiliary equation. Above 0 elements, 8s square plus k marginal. If k equal to 32 here and here, then only it becomes 0. Then auxiliary equation 8s square plus k marginal. So I am writing simple short, okay, short auxiliary equation equal to 8s square plus k marginal, that is a 32. Okay, 8s square plus k. If the k equal to 32, then only complete row 0. Then only we can find the frequency of oscillation. Here also k equal to 32. So take the 8 common here. If you take the 8 common, s square plus 4 equal to 0. S square equal to minus 4. Now s equal to plus or minus, because of minus, j omega, j2. So we can write s equal to j omega. Frequency is asking. Frequency means only we have to write the positive values. Frequency is always positive. So what is the frequency of oscillation? Frequency of oscillation, that is omega equal to 2 radian per seconds. Okay, 2 radian per second. This is a question here. Frequency of oscillation equal to 2 radian per second. Good. Okay, now, yeah, fine. Once again, observe the question. This is a question here. Frequency of oscillation. I hope majority people got the answer. Yes, correct, dear. Yes. Next one, next part here, we have to observe. Yes, one more question. I am checking. Okay. Yes, the system shown in the figure remains stable when? Under what condition system is stable? This means examiner is giving with RH method, they are providing, what is the providing? They are providing one thing, block diagram providing, and also signal flow graph is providing. So to find the stability, we require the characteristic equation. To require the characteristic equation, we require the closed loop transfunction. Closed loop transfunction denominator part is called as a characteristic equation. So whenever the block diagram is given, signal flow graph is given, find the overall gain by using Mason's gain formula. By using Mason's gain formula, find the overall gain. Overall transfunction is nothing but system transfunction, that is nothing but closed loop transfunction. After finding denominator part, take that is called as a characteristic equation, then use the RH method. So this type of questions also asking. Now what is the by using Mason's gain formula? It is a gate question. These are the options are given. These are the options. Come on, yes, check it. What is the correct option here? So SFG question. Now what is the correct option? Now tell me. Yes, I am writing by using Mason's gain formula. Let us. What is the closed loop transfunction here? What is the closed loop transfunction or overall transfunction? Overall transfunction by using Mason's gain formula. Mason's gain. Signal for what means we have to use the Mason's gain. That is a C of S by R of S here. So this is a forward path S4 minus 1. So K by S, that is a numerator term upon denominator term. It is a loop 1. It is a loop 1. Loop 1 here. Loop 1. So 1 we have to write 1 opposite side. Plus 3 is there, minus 3 by S. If you use a Mason's gain formula. Loops we have to write individual loops. Again this is also one more loop. One more loop. Okay, loop 2. So opposite sign we have to take. So minus K by S. K by S. Now take the LCM. K upon S numerator term. After taking LCM, S minus K plus 3. So upon S. Cancel, SS cancel. So what is the closed loop transfunction? Overall transfunction we got it. Overall transfunction equal to, that is nothing but, what is the answer we got it? K upon S minus K plus 3. This term we got. So here what is the characteristic equation? Denominator part is called as a characteristic equation, correct na? So I am taking characteristic equation equal to S minus K plus 3 equal to 0. Now examiner is asking condition for stability. Condition for stability. Now tell me reply. Condition for stability. This is a S power 1, S power 0. Yes. Tell me S power 1 coefficient is 1. This element is minus K plus 3. Okay. Now here give the response. He is asking condition for stability. Condition for stability means careful. It is a positive. For stability already decided. It should also positive. Examiner is asking what is the question? Stability, what is the condition for stability? Condition for stability is asking. So both should be positive, but inside bracket is negative is there. Inside bracket is negative is there. So from this term you have to generate one more negative. So negative become positive. This negative generate negative. So for stability K plus 3 value should be less than 0. For stability K plus 3 value should be less than 0 dear. So K value should be less than minus 3. It is a perfect answer. K less than minus 3. Now, okay, yes, area of you got it answer. Now check it. Yeah, good. Now, yeah, fine, given, students are given. Next one, what I am writing here. Okay, this is a one type of question, one type of model they are asking, and it is a very important. And 2006 was asked, and 2012 also this question was asked here. In the 2006 and 2012 also asked this question. Now just now we were discussing about the signal flow graph now with a block diagram. How to find the block diagram? Your open loop transfunction is given. How to find the characteristic equation? First you have to find the characteristic equation. So characteristic equation is nothing but, now I am writing directly characteristic equation formula is what? 1 plus g of s h of s equal to 0. 1 plus h of g of s h of s. This is a complete part is called as g of s here. This is called as g of s. Now h of s is nothing but 1. So after finding what is the value, you will get your characteristic equation equal to S power 3 plus AS square next to k plus 2s. After simplification you will get k plus 2s s plus, okay, k. Now next to k plus 1 dear. This is the characteristic equation you will get. So by using that formula, now I am using stability condition is asking. Come on, substitute the elements here. S power 3 s square. Now okay, s power 3 s square, s power 1, s power 0 here. Now the coefficients here 1, k plus 2, important, and many times in the prelims also asked, and same model asked in the mains also. Now I am selecting repeated models a and k plus 1 here. Yes, come on, help me here. These two product here, a k plus 2 is a k plus 1 minus k plus 1 upon a equal to, okay, 0. Last one should be k plus 1. So examiner is asking for what is the question here. The frequency of oscillation is given. Frequency of oscillation means frequency of oscillation we are going to find for marginal stability. So for marginal stability, odd number power should be 0. So for ms, what I can write for ms, for marginal stability here, this rho is 0, a minus k plus 2. So what we can write, this is 0 means so a equal what, come on, k plus 1 by k plus 2 dA. This is equation number 1. This should be 0. This is equal to 0. Then a equal what, k plus 1 by k plus 2. And write the auxiliary equation. And also given what is the frequency of oscillation here. Frequency of oscillation is the omega is given. Frequency of oscillation is given. Now okay, omega equal to given 2 here. So what is the given here? Now given frequency of oscillation here. Frequency of oscillation omega equal to 2 radian per second is given. So we can write S equal to j omega, that is a j2 here. Equation number 2. Next, write the frequency of oscillation here. Okay, completed. From the table, frequency of oscillation as square plus k plus 1. So auxiliary equation I am writing as square plus k plus 1 here. Now here substitute what is the s value. What is s value? Tell me. What is s value? Tell me. J2 substitute. J2 means square k plus 1 equal to 0. So minus 4a na? Minus 4a k plus 1 equal to 0. Now next we can write 4a equal to k plus 1. Check it. 4a equal to. What is the a value from equation number 1? K plus 1 by 4a na? 4a. So we can write this element as 4 product of k plus 1 by k plus 2 equal to k plus 1. K plus 1 cancel. So finally k plus 2 equal to how much? Equal to 4. That means k equal to how much will you get? K equal to 2 dear. Okay, this is equal symbol. Now substitute k equal to in equation 1. Substitute it is in equation number 1. So what is the answer will get? Yes, a equal what is the k plus 1 by k plus 2. So 2 plus 1 by 2 plus 2. So we'll get 3 by 4. That is nothing but 0.75. So K, A values are, these are the values 2 comma 0.75 here. So what are the options here? 2 comma 0.75. Option B is right answer here. Option B is right answer. So this question was asked in the gate as well as 2 times gate. Generally the competitive exam question never repeats in the gate, but in the gate it is a repeated question, and also prelims also repeated this question. In the mains also given for ECE as well as electrical for 10 marks. Same question was given for gate, ESE prelims as well as ESE mains also given. Okay, fine. Yes. Yeah, fine. The value of A naught, which will ensure that the polynomial has all the roots in the left of first plane. It is also given question, instrumentation branch. So all the roots in the left of S plane means what is the system here? The system should be stable here. System should be stable. So the given options are given here. What are the options are given? No, I did not write the options here. Options are given here. Okay, options are given. 7 is given, option B is 8 is given, option C 11 is given, option D let us now 5 is given. These are the options are given. So for that stability, all the coefficients should have the same sign. So I am writing now s power 3, s square, s power 1, s power 0 here. So coefficient 1, 2, 1, 2. Now next elements are what? 3 a naught, 3 a naught. So this is 6 minus a naught upon 3, 0. So this is a naught. Is asking all the poles are in the left of S plane means stability. So stability, all the first column elements should have the same sign. It is a positive, it is a positive. This should be positive, this should be positive. So for stability, a naught should be greater than 0 and 6 minus a naught should be greater than 0. So a naught greater than 0 and 6 greater than a naught. That is the condition for stability. A naught less than 6 less than 0. So any value is in between 0 to 6, that system is stable. 0 to 6. This is a greater than 6, wrong option, greater than 6, wrong option, greater than 6, wrong option. Only one option is a D is the perfect answer. D is the perfect answer. Yes. Yes, dear, there should be a time limit. Within that time, we have the 1 hour time session. In the 1 hour, solved almost all models in the Routh-Hurwitz stability. First, I started with the stability system. What is the stability? Within the 1 hour. Actually, it is 7 to 8 hours topic. But within the time 1 hour, I solved maximum all different type of models here. So started with the interview question. What is a stable system? What is an unstable system? What is a marginal stable system? With 2-3 definitions. Okay, different definitions. And also with the animation. Then I moved to the Routh-Hurwitz stability. In the interview point of what is the purpose of stability. Then condition for Routh-Hurwitz stability. Each different models. And I have selected some of the previous questions. Now different models we'll discuss here. Now okay dear, let us now this is a mail ID. If you have any doubts regarding this preparation strategy, yesterday we were discussing about the preparation strategy. No? Now preparation strategy, you have the only September, October, November, December, 4 months only. Only January month you have to dedicate fully for revision. Okay, prepare the short notes. In the month of January, don't touch the new topics. First thing, don't touch the new topics. What are the prepared? Just to revision is required, revision, and prepare the already prepared short notes. So for the short notes, you have to revise and write the every day at least one test. Okay, one test. At least you have to write alternate days, one test here, one mock test, and at the last you have to write the pre-gate exam. Now, okay, this is a mail ID. If you have any doubts, you can mail me. And for more videos, if you want more videos, you can search in the control system, Janish sir, ESE. Okay, ESE also. You have to type ESE also. Then you'll get the more different type of videos in the previous last years. Yeah, fine. From my side, okay dear, it is a time to end the session with one motivation quotation. Yes dear, this is one of my best motivation quotation here. Don't stop when you are tired, stop when you are done dear. So best of luck. Now God bless you dear.